If humans were born and raised on Mars, they would develop taller, leaner bodies with reduced muscle and bone density due to the planet's low gravity. Their lungs would become highly efficient at extracting oxygen from the thin atmosphere, and their skin would darken to protect against radiation. In contrast, surviving on Venus would require a shorter, sturdier body to withstand extreme atmospheric pressure, thick, reflective skin to endure intense heat and acid rain, and reliance on oxygen tanks due to the toxic atmosphere. These adaptations highlight the significant physiological changes needed for human survival on other planets. If you were born and raised on Mars, your body would look very different. Mars might be the best candidate for humanity's future space settlement, but regarding gravity, breathable atmosphere, and liquid water, it is not a place you could survive in your current state. If you tried to walk on the red planet without a spacesuit, you would suffocate, swell, and die of extreme radiation poisoning within minutes. That wouldn't be pretty. To survive Mars's harsh environment, your body would have to adapt significantly. You'd have to be taller and leaner. Martian gravity is only about 38% of Earth's gravitational pull, meaning you wouldn't need much muscle power to walk around. You'd lose bone and muscle density, but that's okay. Your taller frame would use less energy, which is good news because food on Mars would be pretty scarce. Additionally, being taller would help you see further. Speaking of sight, your eyes would need to change. Mars is known for its dust storms, and it's not as sunny there as it is on Earth. Your eyes would have to adapt to these conditions, enabling you to see better in low light. Your tears would also become stickier to protect you from all the dust and debris. Mars barely has an atmosphere, which means two significant changes for your body. First, your lungs would need to become super lungs capable of extracting trace amounts of oxygen from the Martian atmosphere. Second, your skin would turn dark brown to protect you from harmful solar radiation. Without a dense atmosphere, Mars gets bathed in radiation and experiences extreme cold. The temperature on Mars ranges from a comfortable 20 degrees to a freezing cold, 153 degrees. Your dark skin would help absorb more heat to keep you warm during chilly periods. Now consider if you were born on a much hotter planet than Mars. Welcome to Venus. Venus has a dense atmosphere that traps the sun's heat, turning the planet into a furnace. It's so hot on Venus that if you walked outside without a spacesuit, you'd be instantly incinerated. You'd also be crushed under the extreme atmospheric pressure, which is 92 times higher than Earth's. Evolving to live on this hellish world would require a short and sturdy body with thick, silver skin. Your skin would need to reflect intense heat and radiation and neutralize sulfuric acid. Venus's atmosphere is thick with carbon dioxide and clouds of sulfuric acid droplets, so you'd need to withstand Venusian acid rain. Your shorter, more compact body would provide the necessary support to withstand the extreme atmospheric pressure. However, you still couldn't breathe the toxic Venusian atmosphere and would need to rely on oxygen tanks. An active lifestyle on Venus would be impossible because you'd need to conserve energy and whatever oxygen you could get. You'd pretty much be stuck in your living quarters the entire time. Living on Venus would be extremely difficult, even with an extremely sturdy skeleton. In summary, surviving on Mars would require significant physiological changes, such as increased height, reduced muscle mass, enhanced lung capacity, and darker skin. On Venus, survival would necessitate a short and sturdy body, thick, reflective skin, and reliance on oxygen tanks. These adaptations highlight the extreme conditions on other planets and the need for advanced research and technology to make human life possible beyond Earth. Exploring adaptations for human survival on other planets. Mercury. Mercury, being closer to the Sun than Venus, presents unique challenges for potential human settlers. Unlike Venus and Mars, Mercury's lack of atmosphere results in extreme temperature variations. Daytime temperatures can soar to 427 degrees Celsius, while nighttime temperatures plummet to 179 degrees Celsius. Each night on Mercury spans almost 3 Earth months, necessitating significant adaptations for human survival. To withstand these conditions, humans would need a thermal insulation layer under their skin, providing both heat reflection during the day and heat retention at night. This adaptation would give a metallic appearance similar to what would be necessary on Venus. Additionally, a sturdy and stocky body with a layer of fat would help maintain warmth during the long, cold nights, while longer and more flexible limbs would facilitate movement. Due to Mercury's gravity being only 38% of Earth's, muscle mass would decrease, but radiation-resistant cells would be essential due to the planet's proximity to the Sun and lack of atmospheric protection. Breathing on Mercury would be impossible without significant changes. Humans might evolve smaller lungs, capable of storing oxygen, or develop a specialized organ to produce oxygen from ingested minerals, akin to plant photosynthesis. Jupiter. Jupiter presents a vastly different environment. As a gas giant, it lacks a solid surface consisting mainly of hydrogen and helium. Humans attempting to live here would glide through these gaseous clouds. The planet's intense pressure would necessitate a short and compact body structure, and strong muscles would be vital to withstand the gravitational forces. Dark skin would provide some protection against Jupiter's radiation. To navigate Jupiter's thick atmosphere, the human body would need to contain lighter-than-air gases. However, the absence of oxygen in Jupiter's atmosphere poses a significant challenge, making survival without evolving the ability to breathe hydrogen or helium impossible. Saturn. Similar to Jupiter, Saturn's gaseous nature and high atmospheric pressure would demand adaptations like a compact body and radiation-resistant skin. Specialized organs might evolve to synthesize breathable oxygen from water vapor or ammonia, offering a slight advantage over Jupiter. Uranus. On Uranus, humans would need a short, blue-pigmented body for protection against cosmic radiation. Thick skin with heat retention capabilities would be crucial, as Uranus is one of the coldest planets, with temperatures dropping to 224 degrees. Like Jupiter and Saturn, Uranus lacks oxygen and a solid surface, further complicating human survival. Neptune. Neptune presents conditions similar to Uranus, minus the hydrogen sulfide clouds that give Uranus its rotten egg smell. Slightly warmer, Neptune still remains inhospitable for human life, even with evolved adaptations. Titan. One of Saturn's moons, Titan, may offer a more feasible option for human settlement. However, that exploration is a story for another time. In summary, the extreme environments of Mercury, Jupiter, Saturn, Uranus, and Neptune would require significant physiological changes for humans to survive, from thermal insulation and radiation resistance to specialized respiratory adaptations. Each planet presents unique challenges that highlight the need for advanced scientific research and technology to make interplanetary human life possible. Studying how humans can adapt to harsh environments on other planets opens up new possibilities for biology and medicine, helping us better understand the limits and potential of the human body. The challenges of living on other planets drive the development of advanced technology, not only in space exploration, but also applicable on Earth, such as in medical technology and new materials. Imagining and researching settlement on other planets encourages humanity to expand its vision of the future, sparking curiosity and a spirit of exploration, contributing to the continuous progress of humankind. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.